A planet on the brink. Imagine waking up to skies choked with smoke, rivers dried to cracked earth, and relentless storms battering every coastline. This isn't the plot of a science fiction movie, it's the reality unfolding right now. Our planet is screaming for help, and the signs are impossible to ignore. Rising temperatures, melting glaciers, uncontrollable wildfires, and devastating floods are no longer distant threats. They're headlines happening today. The science is irrefutable. The last decade has been the hottest ever recorded. Oceans are heating at unprecedented rates, triggering stronger hurricanes and rising sea levels. The Arctic ice is shrinking, threatening wildlife and altering global weather patterns. Meanwhile, species are vanishing at rates unseen in millions of years. Entire ecosystems are collapsing, and the balance of life on Earth is tipping dangerously. But here's the harsh truth. Despite knowing all this, humanity is still moving too slowly. International agreements like the Paris Climate Accord aim to limit warming, but current emissions continue to rise. Traditional solutions, solar panels, wind turbines, carbon taxes are crucial but no longer enough on their own. The scale of the crisis demands not just effort, but transformation. This is where a new hope emerges, an unlikely ally in the fight for our planet. Artificial intelligence. Imagine machines that can predict disasters before they happen, optimize energy use to near perfection, and design sustainable solutions faster than any human ever could. AI is no longer just a tool for tech companies. It might be the key to our survival. In this video, we'll explore the brutal reality of climate change and then dive into how AI could be our greatest weapon against it. But we'll also ask the hard questions. Can AI be trusted? Who controls it? How do we make sure it works for everyone, not just the privileged few? The clock is ticking. The crisis is imminent. But the solutions are within reach if we dare to act. The harsh reality of climate change, the numbers are terrifying, but they don't lie. Our planet is heating up faster than at any other time in recorded history. Since the Industrial Revolution, average global temperatures have risen by 1.1 degrees Celsius. That may not sound like much, but it's enough to disrupt ecosystems, melt ice caps, and supercharge natural disasters. The consequences are everywhere. Coastal cities are battling rising sea levels that threaten to displace millions. Entire island nations face the terrifying prospect of disappearing beneath the waves within our lifetime. Glaciers in the Himalayas and Antarctica are retreating at alarming rates, feeding floods downstream and destabilizing water supplies for billions. Extreme weather is no longer a fluke, the new normal. Record-breaking heat waves are scorching continents, turning fertile land into deserts. Wildfires are raging longer and hotter than ever before, devastating not only forests, but also the air quality for people thousands of miles away. Simultaneously, floods and hurricanes are becoming more intense, causing massive economic losses and untold human suffering. But climate change isn't just about weather, it's a multiplier of crises. Crops are failing in regions that once fed entire populations. Droughts are fueling conflict over water resources. Diseases once confined to the tropics are spreading to new regions as temperatures rise. The interconnectedness of the planet means no one is truly safe from the ripple effects. Scientists warn that we are dangerously close to several climate tipping points, irreversible thresholds that once crossed accelerate warming and ecosystem collapse beyond our control. These include the melting of the Greenland and West Antarctic ice sheets, the collapse of the Amazon rainforest, and the thawing of permafrost, releasing massive amounts of methane, a potent greenhouse gas. Despite the gravity of the situation, political action remains slow, and global emissions continue to rise. The harsh reality is this: if we do not act decisively and immediately, the window to prevent catastrophic climate change will close possibly within the next decade. The crisis is undeniable, but with every crisis comes an opportunity. What if technology could help us turn the tide? That's exactly what we'll explore next. The urgency for sustainable solutions. There's no time left for half measures. The climate crisis isn't a distant threat. It's here. It's accelerating, and it's affecting every corner of the planet. The urgency for sustainable solutions has never been greater. Scientists warn that to avoid the most catastrophic consequences, we must cut global emissions by nearly half by 2030 and reach net zero by 2050. That S, not a suggestion, that S, a survival deadline. But let's be honest. Traditional solutions, while crucial, are not scaling fast enough. Yes, renewable energy adoption is growing. Yes, governments are pushing policies for sustainability. But the harsh truth is that emissions continue to rise. Fossil fuel consumption is still dominant in many parts of the world. Global supply chains remain deeply unsustainable. Consumer habits are resistant to change, and political will is often short-lived. Why the struggle? It's because the scale of the challenge is massive. Transitioning the entire global economy from energy and transportation to agriculture and manufacturing requires coordination, innovation, and investment on a level humanity has never attempted before. This is why urgency matters. Every year we delay, the solutions become harder, more expensive, and less effective. The impacts of climate change don't wait for legislation, elections, or technological breakthroughs. Ice melts whether or not policies pass. Forests burn regardless of economic debates. But urgency doesn't have to mean panic. It can mean focus. It can mean unlocking human creativity and leveraging every tool at our disposal. Among those tools, a surprising contender is emerging. Artificial intelligence. Imagine AI-driven models that can simulate the entire Earth's climate with pinpoint accuracy, or algorithms that can monitor deforestation in real time from satellite imagery. AI has the potential to accelerate the transition to sustainability, not by replacing human effort, but by supercharging it. The bottom line is simple. Sustainable solutions are not optional anymore. They are mandatory for survival. But the good news is, with the right combination of human determination and technological innovation, they are also achievable. In the next section, we ask a provocative question. Could artificial intelligence actually be the hidden hero in this fight? Artificial intelligence, a potential savior in disguise. When most people think of artificial intelligence, they imagine robots, self-driving cars, or maybe even science fiction nightmares of machines taking over the world. But what if AI is not just a technological curiosity? What if it's a hidden weapon in humanity's battle against climate change? AI has an extraordinary ability to process vast amounts of data faster than any human ever could. It can detect patterns, make predictions, and offer solutions with precision and speed that are simply impossible for traditional methods. In the context of climate change, this power becomes a potential game changer. Let's start with renewable energy. One of the biggest challenges with solar and wind power is their variability. The sun doesn't always shine, and the wind doesn't always blow. AI can solve this. Through predictive analytics, AI can forecast weather patterns and energy demand in real time, optimizing when to store energy, when to use it, and how to distribute it efficiently across smart grids. This reduces waste and makes renewables more reliable. AI is also transforming climate modeling. Traditional models are complex, requiring massive computing power to simulate how the Earth's climate behaves. AI-driven models can process satellite data, ocean temperatures, atmospheric conditions, and more to create more accurate and faster predictions. This helps scientists anticipate extreme weather events like hurricanes, floods, and heat waves, giving communities more time to prepare. And it doesn't stop there. AI can analyze patterns in deforestation, illegal fishing, and wildlife poaching using real-time satellite imagery. This means governments and NGOs can act quickly to prevent environmental damage, before it becomes irreversible. AI's potential extends even to disaster response. Imagine an AI system that monitors earthquake zones, predicts landslides, or even identifies communities most vulnerable to flooding based on hundreds of environmental factors. These are not futuristic dreams. They are already being implemented in pilot programs around the world. But there's an important caveat. AI itself isn't inherently good or bad. It's a tool. Whether it becomes a savior for the planet or simply another mechanism for profit depends entirely on how we choose to develop and deploy it. So the question isn't just, can AI help? The real question is, will we use AI responsibly to save our planet before it's too late? Up next, we'll dive deeper into how AI is already revolutionizing renewable energy production. Revolutionizing renewable energy with AI. The future of energy is clean, renewable, and intelligent, and artificial intelligence is at the core of this transformation. While solar panels and wind turbines are symbols of hope in the fight against climate change, they come with a unique set of challenges. Unlike fossil fuels, renewable energy sources are variable. The sun doesn't shine 24/7, and the wind isn't always reliable. This intermittency makes balancing supply and demand a complex puzzle. Enter AI. AI-powered systems are now being deployed to solve one of the biggest obstacles in renewable energy: predicting and optimizing energy production. Machine learning algorithms can analyze weather patterns, sunlight intensity, wind speeds, and historical energy consumption data to forecast energy generation with stunning accuracy. This allows operators to know when to store energy, when to release it, and how to distribute it efficiently. Take smart grids, for example. A smart grid is an electricity network enhanced by AI that automatically balances energy flow, prevents outages, and reduces energy waste. These systems can make millions of calculations per second, adjusting energy distribution in real time based on both demand and supply conditions. This means more stable power for consumers and less reliance on backup fossil fuel plants. Battery storage is another critical piece. AI helps manage large-scale energy storage systems, ensuring that excess solar or wind energy captured during peak times is efficiently stored and distributed when demand spikes or when production drops. This directly addresses the biggest criticism of renewables: reliability. AI is also helping design more efficient renewable energy infrastructure. From optimizing the placement of wind turbines based on complex terrain modeling to adjusting the tilt of solar panels throughout the day for maximum exposure, AI is pushing renewable efficiency to levels previously thought impossible. Globally, energy companies are already leveraging these AI systems. Google, for instance, uses AI from DeepMind to predict the energy output of its wind farms 36 hours in advance, improving energy delivery to the grid by nearly 20%. Other companies are using AI-driven maintenance predictions to reduce downtime and repair costs for turbines and solar farms. The impact is clear. AI doesn't just make renewable energy, feasibly it makes it smarter. It's more efficient and scalable on a global level. But AI's role doesn't stop at producing energy. The next section will explore how it can help humanity predict and mitigate natural disasters before they strike. It's predicting and mitigating natural disasters with AI as climate change intensifies. Natural disasters are becoming more frequent, more destructive, and more unpredictable. From hurricanes and floods to wildfires and heat waves, communities around the world are facing devastating impacts. But what if we could see these disasters coming earlier and prepare before they strike? That's exactly where artificial intelligence steps in. AI is transforming how we predict, monitor, and respond to natural disasters. Traditional disaster prediction models rely on historical data and basic simulations. AI, however, can process massive amounts of real-time data from satellite images, weather sensors, ocean currents, seismic activity, and even social media feeds to detect warning signs faster and with greater accuracy. For example, AI models can analyze cloud formations, temperature changes, and pressure patterns to predict hurricanes days earlier than conventional systems. These early warnings can save lives, giving governments time to evacuate areas, strengthen infrastructure, and mobilize emergency services. Flood prediction has also seen major advancements thanks to AI. By integrating data from rainfall sensors, river levels, soil moisture, and topographical maps, AI can forecast where floods are likely to occur even down to specific neighborhoods. This enables targeted warnings and faster disaster response. Wildfires are another growing threat. AI-powered systems like NASA S-firms use satellite imagery and machine learning to detect wildfire hotspots in near real time. Combined with predictive modeling, AI can forecast how fires might spread based on wind, humidity, and vegetation, allowing firefighting teams to deploy resources more effectively. Even earthquakes, traditionally seen as unpredictable, are being studied with AI. Researchers are training algorithms to detect subtle patterns in seismic activity that may precede major quakes. While this field is still developing, early results are promising. Beyond prediction, AI is helping during the disaster itself. AI chatbots assist with emergency communication, while drones powered by AI survey disaster zones to locate survivors and assess damage more quickly than human teams alone. Mitigation is equally important. AI can help cities design flood-resistant infrastructure, optimize evacuation routes, and plan urban spaces to be more resilient against climate-driven disasters. In short, AI doesn't just help react to disasters, it helps prevent them from becoming catastrophes. It gives humanity a fighting chance in an increasingly unstable climate. Up next, we'll dive into real-world examples of how AI-driven climate solutions are already making a difference today. Real-world AI solutions fighting climate change today. AI's role in combating climate change isn't just theoretical, it's already happening right now across the globe. From startups to tech giants and governments, innovative AI-driven solutions are actively reducing emissions, protecting ecosystems, and helping communities adapt to climate threats. Let's start with energy. Google's DeepMind has successfully deployed AI to manage the energy output of wind farms. By predicting wind patterns up to 36 hours in advance, the AI boosts energy output efficiency by nearly 20%, making renewable energy more reliable and profitable. Similarly, IBM's Green Horizon project uses AI to forecast air pollution levels in major cities like Beijing, enabling governments to issue warnings and implement traffic control measures to reduce harmful emissions. In agriculture, AI-powered systems are revolutionizing how we grow food sustainably. Companies like Blue River Technology use AI-driven robots to identify and spray herbicides only on weeds, reducing chemical use by up to 90%. This not only lowers pollution, but also cuts costs for farmers. Meanwhile, precision farming platforms like Climate Field View combine AI with satellite data to help farmers monitor soil conditions, predict crop yields, and optimize water usage, minimizing waste and maximizing production. Wildlife conservation is another area where AI shines. Organizations like Global Fishing Watch use AI and satellite data to track illegal fishing in real time, helping protect marine ecosystems. AI is also being used to monitor endangered species by analyzing sounds from rainforests or images from camera traps, detecting poaching activity or identifying animal populations faster than humans ever could. In disaster response, the UN's Global Pulse Initiative leverages AI to analyze social media, phone data, and satellite imagery to detect humanitarian crises as they unfold, whether it's a flood, famine, or a disease outbreak. This allows for quicker, more targeted responses that save lives. AI is even helping cities go green. Smart traffic management systems powered by AI reduce congestion and emissions by optimizing traffic lights based on real-time data. Buildings' AI-driven systems manage heating, cooling, and lighting to reduce energy consumption significantly. These are not isolated experiments, they are scalable models that can be adopted worldwide. The takeaway is clear. AI is no longer just a tool for the future. It's a vital part of our climate solution toolbox today. But as we embrace these innovations, the question becomes, how do we unleash the full potential of AI to build a truly sustainable world? That's exactly what we'll explore in the next section. Unleashing AI's power for sustainable technologies. AI, ICE and T just helping us manage what exists. S, actively driving the creation of new sustainable technologies that could redefine our future. From cleaner construction materials to smarter food systems, AI is playing a crucial role in designing a world that is both efficient and environmentally responsible. Let's start with carbon capture and storage. AI enhances CCS by optimizing how and where carbon dioxide is captured from industrial processes. Machine learning models predict the best geological sites for storing carbon and monitor them over time to prevent leaks. This technology turns major carbon emitters into potential carbon sinks, dramatically reducing their environmental footprint. In the construction industry, AI is accelerating the development of eco-friendly materials. Researchers are using AI to analyze chemical compositions and simulate how new materials will perform under different conditions. This has led to the creation of low-carbon concrete biodegradable insulation, and even bricks made from recycled plastic or algae, each significantly cutting emissions compared to traditional materials. Agriculture is another frontier where AI shines. Precision agriculture leverages AI to monitor soil health, forecast crop diseases, and automate irrigation based on weather predictions and soil moisture data. AI-powered drones scan entire fields, spotting early signs of pest infestations or nutrient deficiencies, allowing farmers to act quickly and minimize chemical use. This means higher yields with fewer resources, critical for feeding a growing global population without destroying ecosystems. Circular economies are also gaining traction thanks to AI in waste management. AI-driven robots sort recyclables from trash with incredible accuracy, reducing contamination and improving recycling rates. AI models help design products with disassembly in mind, ensuring that materials can be recovered and reused rather than ending up in landfills. Smart grids are another AI-driven innovation, optimizing energy distribution in real time. They balance electricity flow based on demand, supply, and storage, incorporating renewables seamlessly while reducing energy loss. Even fashion is getting an AI makeover. Brands are using AI to predict demand, reducing overproduction and waste. Some companies are experimenting with AI-designed fabrics made from plant-based or recycled materials. In essence, AI isn't just patching the holes of a broken system, it is helping build a fundamentally new, sustainable one. This shift has the potential to transform industries, reduce our ecological footprint, and move humanity toward a more harmonious relationship with the planet. But while the promise of AI-driven sustainability is immense, it's important to pause and consider the ethical dilemmas that come with it, a crucial topic we'll tackle next. Ethical considerations in AI-driven climate solutions. As powerful as AI is in combating climate change, it's not without ethical dilemmas. While the technology promises transformative solutions, it also raises serious questions about fairness, privacy, job displacement, and who ultimately benefits from these innovations. Let's start with data privacy. AI thrives on data, massive amounts of it. Predicting weather patterns, managing smart grids, or tracking resource usage requires gathering information from satellites, sensors, and even personal devices. But who owns this data? How is it protected? Without strong safeguards, sensitive information about individuals, businesses, and communities could be misused by corporations or governments. Another major concern is bias in AI algorithms. AI models are only as good as the data they're trained on. If the data reflects historical biases, whether socioeconomic, racial, or geographic, the AI will perpetuate them. For example, an AI designed to allocate resources for climate resilience might favor wealthier regions with better data availability, while underserving poorer or rural communities. This can exacerbate existing inequalities rather than solve them. Job displacement is also on the table. As AI automates tasks in energy management, agriculture, waste sorting, and manufacturing, certain jobs will become obsolete, while new jobs will undoubtedly emerge, especially in AI maintenance, data science. In green technologies, the transition could be painful for workers in traditional industries. Less governments and companies invest heavily in retraining programs. Then there's the question of access. The most advanced AI-driven climate solutions are being developed by wealthy nations and large tech companies. If lower-income countries or marginalized communities are left behind, the gap between the climate-resilient and the climate-vulnerable will only widen. Ensuring equitable access to AI tools is not just a moral imperative, it's essential for global climate success. AI itself has a carbon footprint. Training large machine learning models requires vast computational resources, consuming energy, and generating emissions. If the energy behind AI isn't sourced from renewables, the technology meant to save the planet could end up contributing to the problem it seeks to solve. Lastly, there's the issue of transparency. Many AI systems operate as black boxes, with decisions made in ways that even their creators struggle to fully understand. For climate solutions, this opacity can be dangerous. Communities affected by AI-driven policies deserve to know how those decisions are made and to have a say in them. In summary, while AI offers unprecedented opportunities to tackle climate change, it must be developed and deployed with careful ethical oversight. Transparency, fairness, privacy, protection, and equitable access should be non-negotiable principles guiding this technological revolution. In the next section, we'll explore how to design AI systems that align with these ethical values while maximizing their environmental impact. Designing ethical and transparent AI for climate action building. AI systems that address climate change effectively requires embedding ethics and transparency from the very beginning. This means designing algorithms and technologies that are not only powerful, but also fair, accountable, and understandable to all stakeholders. First, transparency is crucial. AI models used in climate applications should be explainable. meaning their decisions and predictions can be traced and understood by humans. Explainability helps build trust among policymakers, scientists, and the communities affected by AI-driven decisions. For example, if an AI system recommends resource allocation during a flood, stakeholders must understand how and why those recommendations were made to ensure accountability. Fairness must be prioritized throughout development. This involves using diverse and representative data sets that reflect the needs and realities of all communities, especially vulnerable and marginalized groups. Developers should continually test AI outputs for bias and adjust algorithms to correct disparities. This proactive approach helps avoid unintended consequences that could worsen social inequalities. Privacy safeguards are non-negotiable. AI systems must handle sensitive data responsibly, incorporating privacy-preserving techniques like data anonymization and secure data storage. Clear policies on who can access data and for what purposes must be established, ensuring compliance with legal and ethical standards. Another key principle is inclusivity. Engaging diverse stakeholders, scientists, ethicists, community leaders, and policymakers in the AI design process fosters a holistic perspective. This collaborative approach ensures that AI solutions address real-world challenges in a socially responsible way. Moreover, sustainability should be integrated into AI development. This includes minimizing the carbon footprint of AI training and operations by using energy-efficient hardware, optimizing algorithms to reduce computation, and prioritizing renewable energy sources for data centers. Human oversight remains essential. While AI can provide powerful insights, final decisions should involve human judgment to interpret context, values, and unforeseen consequences. Establishing frameworks where AI supports, rather than replaces, human decision-making is critical for responsible climate action. Lastly, governance structures and regulations need to evolve alongside AI innovations. Clear standards and accountability mechanisms must be established at national and international levels to monitor AI's use in climate efforts and ensure ethical compliance. In essence, designing ethical and transparent AI is not just about technology. It is about embedding human values into every step of AI's role in fighting climate change. Only then can we harness AI's full potential responsibly. Next, we'll look at how global collaboration can amplify AI's impact in creating a sustainable future. Global collaboration, harnessing AI for climate action. The fight against climate change demands a united global effort. AI, with its vast potential, can accelerate solutions, but only if countries, organizations, researchers, and businesses work together seamlessly. International cooperation enables data sharing across borders, which is critical for developing accurate climate models and early warning systems. AI thrives on diverse, comprehensive data sets, and no single nation has all the information needed. Initiatives like the World Meteorological Organization's Global Framework for Climate Services exemplify how pooling resources benefits everyone. Collaboration also means harmonizing standards and regulations. As AI tools spread worldwide, consistent ethical guidelines, data privacy rules, and transparency requirements help ensure responsible deployment. Without this, AI could exacerbate inequalities or even be misused for harmful purposes. Public-private partnerships are key drivers in innovation. Companies bring technological expertise and investment, while governments provide regulatory frameworks and social priorities. Together, they fund AI research that balances cutting-edge developments with public good. For instance, the European Union's Horizon Europe program supports AI projects focused on environmental sustainability. Academic institutions and NGOs also play a vital role, conducting independent research and advocating for marginalized communities. Their involvement ensures AI-driven climate strategies are inclusive and equitable. Engaging local communities is equally important. AI solutions tailored without local input risk being ineffective or rejected. By involving those directly affected, solutions become culturally relevant and more sustainable. Global forums such as the United Nations Climate Change Conferences provide platforms to coordinate AI strategies within the broader climate agenda. These gatherings foster dialogue, share best practices, and mobilize funding. However, collaboration isn't without challenges. Geopolitical tensions, data sovereignty concerns, and uneven technological capacity can hinder cooperation. Addressing these requires diplomacy, trust building, and capacity building programs. In short, harnessing AI's full potential against climate change depends on breaking down silos and working as one global community. The stakes couldn't be higher. Our planet's future depends on it. Next, we'll explore ways individuals can engage with AI-powered sustainability efforts. Individual action. Engaging with AI-powered sustainability while AI's impact on climate change can be immense at the global and industrial levels. Individuals also play a critical role in harnessing this technology for sustainability. Understanding how we can engage and support AI-driven climate solutions empowers each of us to contribute meaningfully. One way individuals can get involved is by supporting smart products and services that leverage AI to reduce environmental impact. This includes using energy-efficient smart home devices that optimize electricity usage, apps that monitor personal carbon footprints, or even sustainable shopping platforms that recommend eco-friendly products based on AI analytics. Awareness is key. Learning about AI's potential and limitations allows consumers to make informed choices and advocate for responsible AI development. Online platforms and community groups often provide educational resources about AI and climate action. Joining these can amplify your voice and connect you with like-minded people. Participating in citizen science projects powered by AI is another impactful option. Many initiatives rely on crowdsourced data to train AI models, for example, apps that track local biodiversity or air quality. Contributing data or observations helps improve AI's accuracy and relevance, while fostering a deeper connection with the environment. Individuals can also pressure governments and companies to prioritize sustainable AI, voting for policies that promote green technologies, supporting businesses committed to ethical AI use, and holding leaders accountable through activism. All help shape a sustainable AI future. Privacy-conscious behavior is essential too. Since AI depends heavily on data, protecting your own data privacy and encouraging transparent data practices help build trust in AI systems and prevent misuse. Finally, adopting a sustainable lifestyle complements AI-driven efforts. Reducing waste, conserving energy, and choosing renewable options create demand for green technologies and reduce the overall environmental burden. In essence, individuals are not passive observers, but active participants in the AI-powered sustainability revolution. By embracing technology thoughtfully and advocating for ethical innovation, each person helps build momentum toward a healthier planet. Next, we'll look at some inspiring real-world examples of AI making a difference today. Real-world success stories. AI making a difference today? Artificial intelligence is already playing a pivotal role in tackling climate change through innovative projects worldwide. These real-world examples show how AI-driven solutions can produce tangible environmental benefits. It's inspiring hope for the future. One notable success is Google's DeepMind AI optimizing energy use at their data centers. By analyzing vast amounts of operational data, the AI improved cooling efficiency, reducing energy consumption by up to 40%. This innovation not only cut costs, but also lowered carbon emissions significantly. Setting a standard for greener tech infrastructure. In agriculture, startups like Blue River Technology use AI-powered robots to identify and eliminate weeds selectively. Its precision farming reduces herbicide use, which benefits soil health and biodiversity. Smart irrigation systems guided by AI analyze weather and soil data to optimize water usage, conserving precious freshwater resources. Disaster management has also seen breakthroughs. AI platforms like OneConcern use machine learning to predict the impact of natural disasters such as floods and earthquakes in real time. Governments and emergency responders leverage these predictions to plan evacuations and allocate resources more efficiently, saving lives and minimizing damage. In the energy sector, companies are deploying AI to integrate renewable sources like solar and wind into the power grid smoothly. AI algorithms forecast energy production based on weather patterns, balancing supply and demand dynamically to avoid blackouts and reduce reliance on fossil fuels. Recycling initiatives benefit from AI-powered sorting robots that can identify and separate materials with greater speed and accuracy than humans. This improves recycling rates and decreases landfill waste, promoting a circular economy. Moreover, climate scientists use AI to analyze satellite imagery and environmental data, tracking deforestation, glacier melt, and ocean health. These insights inform policy decisions and conservation efforts. Now, these examples illustrate that AI is not just a theoretical tool, but an active agent in climate solutions worldwide. While challenges remain, the progress so far demonstrates AI's potential to scale sustainable practices across industries. Next, we discuss the future prospects of AI in combating climate change and what innovations might be on the horizon. The future of AI in climate action holds immense promise, with emerging technologies and novel approaches poised to revolutionize how we understand and address environmental challenges. One exciting frontier is the advancement of AI-driven climate modeling. Future models will incorporate more granular data such as local microclimates and real-time sensor inputs enabling unprecedented precision in predicting weather patterns, sea level rise, and extreme events. This will improve preparedness and resource allocation on a global scale. Another breakthrough area is AI-powered material science. Researchers are developing algorithms to design new sustainable materials with properties like carbon capture capability, biodegradability, and high strength-to-weight ratios. These materials could transform industries from construction to packaging, drastically reducing carbon footprints. AI is also expected to enhance carbon capture and storage technologies. Smart sensors combined with AI analysis can monitor CCS sites in real time, ensuring safety and efficiency. Additionally, AI could optimize the chemical processes involved in capturing carbon dioxide, making these technologies more cost-effective and scalable. In the energy sector, AI may drive the creation of fully autonomous, self-healing power grids. These smart grids will dynamically reroute energy flows to maximize efficiency, integrate diverse renewable sources, and detect faults before failures occur, reducing downtime and emissions. Agriculture will benefit from AI-integrated drones and robots that can monitor crop health, soil conditions, and pest activity at a scale and detail previously impossible. This precision will boost yields, conserve water, and reduce chemical use. AI's role in climate finance is also growing, with algorithms assessing risks and opportunities linked to climate change to guide investments in sustainable projects. This will help channel more capital toward green innovations. Furthermore, combining AI with other emerging technologies such as blockchain for transparent carbon trading and IoT for interconnected environmental monitoring will create synergistic solutions. However, realizing these future innovations requires sustained investment in research, interdisciplinary collaboration, and ethical governance to ensure AI benefits all. The potential is vast, but our actions today will determine how effectively we harness AI to secure a sustainable planet. Next, we'll discuss how education and public awareness are crucial to supporting this AI-powered climate future. Education and public awareness, building support for AI-driven climate solutions. For AI to reach its full potential in combating climate change, educating the public and raising awareness about its capabilities and limitations is essential. An informed society can better support and engage with AI-powered sustainability initiatives. Educational programs should begin early, integrating AI and environmental science into school curricula to prepare future generations, teaching students about how AI can analyze data, optimize resources, predict climate impacts, helps demystify the technology and inspire innovative thinking. Public awareness campaigns play a critical role in dispelling myths and addressing fears around AI, such as concerns about privacy or job displacement. Transparent communication about how AI works in climate efforts fosters trust and encourages responsible adoption. Media outlets and influencers can amplify messages about AI's role in sustainability, showcasing real-world success stories and practical ways individuals can contribute. Documentaries, podcasts, and interactive websites also engage diverse audiences. Community workshops and citizen science projects offer hands-on experiences with AI tools, enabling people to see firsthand how technology aids climate monitoring and conservation. This empowerment builds grassroots support. Governments and NGOs should invest in accessible resources that explain AI concepts clearly and highlight ethical considerations. Inclusive outreach ensures marginalized groups are not left behind in the AI revolution. Moreover, interdisciplinary education combining computer science, environmental studies, ethics, and policy prepares professionals who can design and manage AI solutions responsibly. Ultimately, a well-informed public not only supports policy decisions favoring sustainable AI, but also advocates for transparency, fairness, and human-centered design. By building broad awareness, we create a collaborative environment where technology and society work hand in hand toward a resilient, climate-safe future. Next, we'll explore how policy and regulation shape the development and deployment of AI for climate action. Policy and regulation. Shaping AI for effective climate action. Effective policy frameworks and regulations are critical to ensuring that AI technologies are developed and deployed responsibly in the fight against climate change. Governments worldwide must create guidelines that balance innovation with safety, ethics, and equity. First, establishing clear standards for data collection, sharing, and privacy is essential. AI relies on large datasets, but without proper safeguards, there is a risk of misuse or breaches of sensitive information. Regulations must protect individuals while enabling the flow of environmental data necessary for accurate climate modeling. Secondly, policymakers need to address potential biases in AI algorithms. Biased systems can lead to unfair resource distribution or misinformed decisions that disproportionately affect vulnerable communities. Transparent auditing and accountability mechanisms can mitigate these risks. Investment incentives are also crucial. Governments can promote AI research targeting sustainability through grants, tax breaks, and public-private partnerships. Such funding accelerates innovation while directing efforts toward the greatest environmental needs. International cooperation on AI governance enhances consistency and fosters collaboration. Harmonized policies reduce fragmentation and encourage the sharing of best practices and technology across borders. Environmental regulations can mandate the use of AI for monitoring pollution, enforcing emissions limits, or optimizing resource usage. This encourages industries to adopt AI-driven sustainability measures. However, regulatory approaches must remain flexible to adapt to rapidly evolving AI technologies. Overly restrictive rules risk stifling innovation, while lax oversight could lead to harm. Stakeholder engagement is vital. Involving technologists, ethicists, environmentalists, affected communities ensures policies are balanced and inclusive. Ultimately, smart governance creates a framework where AI can thrive as a tool for climate resilience and sustainability, maximizing benefits while minimizing risks. Next, we'll discuss the ethical challenges and responsibilities surrounding AI in environmental contexts. Ethical challenges and responsibilities of AI in environmental sustainability. As artificial intelligence becomes increasingly integral to climate solutions, it brings a set of complex ethical challenges that must be carefully managed to ensure fair and responsible use. One major concern is data privacy. AI systems often rely on vast amounts of personal and environmental data, raising questions about consent, ownership, and potential misuse. Protecting individuals' rights while enabling effective climate modeling is a delicate balance. Another challenge is the potential displacement of jobs. Automation of certain environmental monitoring or resource management tasks could impact workers, especially in vulnerable communities. Ethical deployment requires planning for workforce transition and reskilling programs. Bias in AI algorithms can perpetuate inequalities. If AI systems prioritize data from wealthy regions or exclude marginalized groups, climate solutions may become unevenly distributed, exacerbating social injustices. Developing transparent, inclusive algorithms is essential. There is also the risk of over-reliance on AI, where technological optimism overshadows the need for systemic social and political changes to address climate change. AI should complement, not replace, human decision-making and community engagement. Environmental impacts of AI itself must be considered. Training large AI models consumes significant energy, potentially contributing to emissions. Developing energy-efficient AI and sourcing renewable energy for data centers helps mitigate this footprint. Accountability is key. Clear guidelines are needed for responsibility when AI systems fail or cause harm. Human oversight and governance structures ensure ethical use. Ultimately, ethical AI in environmental sustainability demands collaboration among developers, policymakers, communities, and ethicists to create standards that uphold justice, transparency, and human dignity. Next, we'll examine the role of international collaboration in maximizing AI's climate impact. International collaboration, uniting for a global AI/I-powered climate response. Climate change is a global challenge that transcends borders, making international collaboration essential to harnessing AI's full potential for sustainability. Nations must work together to share AI technologies, data, and best practices to accelerate climate solutions worldwide. Collaborative platforms enable pooling of resources, knowledge, and expertise, which is especially important for supporting developing countries that may lack advanced AI capabilities. Global agreements can set common standards for AI governance and climate action, addressing ethical concerns, data privacy, and equitable access. Harmonized regulations facilitate cross-border projects and reduce duplication of efforts. International research partnerships drive innovation by combining diverse perspectives and talents. Initiatives like the United Nations AI for Climate Change Task Force foster dialogue between governments, private sector, academia, and civil society. Funding mechanisms coordinated at the global level can ensure investments flow to high-impact AI projects addressing climate risks and sustainability goals. This collective financial support can bridge gaps and scale successful pilot programs. Furthermore, international collaboration promotes transparency and trust, crucial for deploying AI in sensitive areas like environmental monitoring and disaster response. By uniting efforts, the global community can maximize AI's benefits, tackling climate change more effectively than isolated national efforts. Ultimately, addressing the climate crisis requires a shared commitment to innovation, ethics, and cooperation, a mission where AI plays a pivotal role.